Okay, now everybody can see, I believe. So I'm on YouTube also, and I'm on this thing also, right? So let me add all the students. Okay, let me share my screen and then we can explore. So just allow me a minute. Okay. Yeah. Just bear with me for a minute. Okay, so I am sharing my screen. Just allow me a minute, and then we are good to go. Okay, I got the PPT. It's ready. Let me share my screen. Entire screen. Allow. I believe is my screen visible to all? Okay, that's great. Okay, so first of all, formally, very good morning to all, and I really apologize related to that. I joined late due to this connectivity issue, right? So today, what we are going to do, we are going to do an ELC activity with Arduino based. So ideally, what this Arduino means, talk about robotics, right? So since I will just give my basic background. Yeah. So I'm just giving my basic background. I'm Dr. Sachin Gansal. I'm working as an associate professor in computer science department, and I was a postdoctoral fellow at University of Queensland. I did my PhD from IIT Delhi. I did my master's from IIT Allahabad. So I have a basic background of primarily in the domain of robotics, computer vision, and machine learning, right? So in a nutshell, I am working in the field of robotics for the past 13 to 14 years, right? Right from the starting with the exoskeleton, mobile robotics, manipulators, right, machine learning, and all that domain I'm working, right? So I'll take two ELC activity every year. One activity is based on simulation or based on Tinkercad, where a student can explore how you can design a layout, how you can design any kind of an IoT system, right? And then later in the stage, how you can develop that system and deploy in the real time. That will be our ELC activity 2. We call it as ELC activity robotic arm, right? So in this activity, what we are trying to achieve is how you can explore that. Okay, if you need to develop, let's say for example, if you need to develop a smart home, right? And in the smart home, you need to develop different sensors, and you need to interface that sensor into one unit, control unit, maybe Arduino, maybe Raspberry Pi, maybe Jetson Nano, and how you are going to use it in the real time, right? So initially, in order to deploy in the real time, you need to do it in the simulation, right? So this activity, let me add the people, because I think just allow me a minute, because I need to add students. Admit all. Okay, right. Okay, right. So in this, we need to explore that what kind of activities that we need to start with, right? Okay, so the introduction of this activities, it involves designing and implementing various applications like smart home, pollution controller, intelligent traffic system, robotics, right? So you can start with, let's say, smart home, right? So let's say if I give an example, if I given a test case, let's say, okay, can you make a smart home where your AC automatically switch off when no one is there in the room? Second, your doors open automatically when someone's knocked the door. Third, you can automatically water your plant if the plant dried up or needs some kind of an extra treatment, right? Fourth, can you make sure you are not wasting any water automatically? If you're if you're washing your hand, automatically the water got stored in a different container so that you can reuse it, right, later in the stage. And similarly for different cases, right? In terms of, let's say, intelligent traffic system, right? How you can develop a system where automatically where you have heavy traffic will be having a green signal, rather than the traffic where the congestion is low. How you can give all the green channel to a let's say ambulance. So all these things fall under the category of intelligent system. Whenever I say robotics, so robotics itself is not a new thing nowadays. It's again an amalgamation of different domains, and you club it into one entity, right? So in that perspective, we have to explore more in detail, right? So during the activity, students have to work with the sensors, LCD screen, other modules, and they need to do it interfacing with Arduino. So still in Arduino, you have multiple categories. Let's say, for example, you have Arduino Uno, you have Arduino Mega, you have Arduino Micro. Arduino is there, right? So based on the computing power, based on the input-output channels, based on the kind of an control unit, you can choose different Arduino. We can use Raspberry Pi, Jetson Nano, but for this stage, we are looking forward to start with Arduino. I must know that I'm sure that many of the people already worked in Arduino, right? The audience, but still we have to take everyone on the same panel, and then we have to explore more in detail, right? So this hands-on session will be a fun, engaging way to learn with fellow friends and mentors. So what would be the intention of this activity is, I'll give you a brief exploration of the activity. Based on this, I will be giving some problem statements and that you need to submit over the LMS. I will be giving some time, let's say for 15 or 20 days. In 15, 20 days, you have to submit individually. There is no group, right? Individually, you have to choose a entity, and based on the problem statement, you need to give a solution. You need to submit the file. You need to submit the code. Everything you have to submit over the LMS, right? Yeah, I think is everything is okay. Everybody, anyone can raise your hand, or may anyone say yes, sir. We can go ahead. Okay, that's good. Let me add other people because side by side I have to add students here. I think all are here, I believe. Okay, I just need to check the live streaming is there. Yes, okay. Fine. Okay, so let me go to the board. Okay, right. Okay. So what are the objectives of this ELC activity is? First, need to explore the Arduino platform via Tinkercad. So let's understand what this Tinkercad is. Tinkercad is like an online platform where you can log in as a student entity, and it's completely free if you're a student entity. And based on that, you can develop a simulation entity where you can use various sensors, interfacing it, connecting it to the LCD, connecting to motors, connecting it to the sensors, do some coding, process the data. Based on the data, based on your condition, it will give some output, some condition, some activity has to be done, and you can visualize the objective, right? You can visualize what you want to achieve from that, and if it is perfectly matches with you, you can definitely copy this, which is called sim to real. Sim to real means you develop an algorithm in simulation, and now you need to deploy in the real time. So you need to transfer your constraint, your data, your results from a simulation to a real time. Definitely there are challenges in order to convert from sim to real, that's for sure, but there are multiple methods, technologies are available where you can directly deploy your simulation result into deployment, keeping you have the hardware, keeping you have the sensors, right? So in this activity, it's completely simulation based experiential learning. Later in the stage, in the next semester, when we are having hands-on actual kit of robotics arm, it will be very helpful for you if you have basic exposure to Arduino at this stage, right? Last but not the least, to foster creative thoughts, process in developing solutions for real world problems, right? What is the execution plan? So introductory session, let's say we'll have today, we're already going introduction to basic robotics, Tinkercad basics. What are the problem statements? I will be giving you sample project execution. And based on this, I'll be also helping you with a helping manual. I will be sharing a helping manual with you so that you can explore more in detail. And then you have to submit an assignment. The assignment, I will be giving around 4 to 5 problem statements. Based on the problem statements, you have to explore the helping manual, and taking the help from helping manual, you can do that exercise, and it's pretty basic exercise. I urge you, all of you, to work of your own. Don't copy from others, because it's like ELC. It's nothing I'm going to give you some grade, right? So it's completely, you have to explore of your own, and I will look forward if you can get some very good response from it, right? And I've got very good experience from all my ELC activities. Is student got engaged into this, they got to learn about robotics, and eventually, organically, it will become, they will explore more in detail the robotics part, and then they explore more in detail. Let's, for example, then they sometimes they reach out to me, sir, I want to work in this domain, what are the new papers available? And I have got very good experience with my students. We have lots of papers. If you want, you can visit. I have lots of papers with my undergraduate students. I published, I think, on fortnightly basis, every 15-20 days. I have something to show. I'll put everything on the LinkedIn, right, tagging my students, and we have make a very good ecosystem here, particularly in the domain of research and hands-on, right? Okay. There are sample projects. Let's say, for example, this is the one project. It's called digital clock. It means you need to connect this Arduino, right, with some sensors, right, with some timer diagram, and based on that, it will give a digital clock. It's a smart dustbin system. For example, let's say, for example, if someone is coming close to the smart system, smart dustbin, there is a ultrasonic sensor. If you're coming, it will detect. It will sense, okay, someone is coming. Maybe he wants to dump some waste. Automatically, it will process this data. There is a battery that will give the power to this Arduino, and based on this motor will execute. It will move in the anti-clockwise or clockwise based on your coding. It will open the box or bin, you put it, and once you go away from the dustbin, again it will sense, okay, now the person is not near to or in the vicinity of that dustbin, it will close, right? So based on all these scenario, you can develop any sample project. These are the pretty basic sample projects. There are a couple of projects that are need very hefty understanding of coding, so it depends upon your exposure. I'll be giving some beginner level, intermediate level, and expert level, right? So there will be one problem for each student. Ideally, I'll share 9 to 10 problems. You can pick one. So within this one module, you have 3 levels: the initial problem statement, beginner for beginners, then intermediate, and then for expert. Everyone has to attempt 3 levels of each question, right? So that you can explore more in detail. Rather than doing 3 beginner problems, I will ask student to try one problem with all the 3 stages, so that you can know the sequence, so that you can know the complicacy, so that you can see within the same problem how the problem can be tackled in a different way based on the real-time scenario. Because let's say, for example, if I add in the smart dustbin, how you're going to tackle with the rain, right? You have sensors. What is going to happen when the very heavy rain is happening and you are using a smart dustbin and there is no shade? How are you going to tackle that problem, right? So all these things change. Your solution should change based on the condition, right? I think all are with me, right? Okay, so let me switch my PPT from here to the dashboard. I think, okay. Let me, yes. Are you able to see my screen? Okay, everybody is able to see my screen. Over the live chat, I'm not sure whether they are able to see my screen. Let me share from here also. Let me. I think I should have to do this. Tie screen, allow. Now I think over the YouTube you can see, right? Okay. So this is the layout of a Tinkercad. You can see. You can just type Tinkercad Autodesk. You will be asking for making a login. Just do the login, register as a student, and then you can do all these things: 3D analysis, right? Circuit analysis, where you can do the circuit analysis. There will be code blocks, how you can design the code blocks, right? All that can be done here itself, right? Let's start with any basic program. Let's start with this. So I'll opening a new tab. Okay. Now you can see, just I am giving a basic background. So here is the digital pins. These are the analog pins, and these are the power. It means if you want to execute anything at the output level, everything should be on the digital pin, right? If you want to give any supply, so this is you can see, if I do this, I think that will be better to understand or visualize. This is ground. Red is ground. Let's say red is positive. Then you have ground, and then you have VIN. It means you are giving some voltage to this motor. You are giving this voltage to these red LED and blue LED, and the output is also coming. So 10 is coming to green LED, 8 is going into red LED, and 9 is going to your motor. So every servo motor has 3 components. First is your power supply, your ground denoted by black, and the green is denoted by the output pin. So your output pin of this motor is connected to 9 pin of Arduino. It means anything that is executing here will be giving output at on the 9th pin, right? Let me simulate this, what it will, and even you can code this thing. I'll also go with that code also, right? So let's start simulating. Once I do the simulation, this will pin up this. It means you got the supply. So now it's connected, right? Now based on this, it is now showing doing green, and it is moving. After it complete, let's say 90-degree, right? It will again 45-degree. Let's say it will again go to orange. It will once reach to this, again it will move to another direction, and this LED will be glow. So now you can see the switch, right? Are you able to see? Whenever he's moving in this direction, the green LED is glowing. Whenever he is completing the rotation, now again switching, the red is blinking, right? So these things you need to explore, right? So now how you can code this thing. So now again going to the code, as you can see here, you just go with the code side. Yeah. Me. Now you can see the code. So servo setup 9, white setup, you attach this pin mode 8. If you recall, 8 is your LED connected and is your green connected. So this is like an initial setup, how your servo is attached. So servo is attached to the 9th pin. Let me see where it is. If you are able to see, I think, let me, no issue. Ideally, what is happening? Initially, it is starting from 0. It will count till 20, and every time it is adding up. So tell servo to go to position in value pose, and again switch. So let's say if I go here till, let's say 40. I think let me check whether I can change it, because I'm on running mode, I believe. Okay. I think I have to log in, then only I can add it. If let's, for example, if you added this from 20 to 40, it means it will go till 40, and every time the counter will become pose equals to 2 plus pose, then again 2 plus pose, and so on and so forth, right? Let me, if I just want to execute on my portal, so just allow me a minute. At the time I'll add, or the students, I think all are here, right? Yeah. Okay, now I can see. Now if you just go to this code, now you can check. The servo is attached to pin number 9. Let me check. The servo is attached to pin number 9. That's okay, right? The 8 is connected to LED red. 8 is connected to LED red. Yes, fine. LED red is 8 pin connected. That's okay. 10 is connected to green LED. 10 is connected to green LED. That's perfectly fine. Okay. Now I want to go till 40, and every time I want addition of 4 pause every time, right? So if I do the save, right, and I do the smart simulation, let me check how it works. So now you'll see the motion is on a higher side. It will go till 40 motions. Previously it was 20, and even you can see the motion is on a higher side, right? Now if I want to again check, if I want to go and I want to have it 8 times, and I have to start with, let's say, 60, and here I want to start with 60. It means again we are having more motion but on a side. Let's say like this. Again I'll do the save, and again if I run this code, let's see. So now the motion is on a higher side and the rotation will be going far better. Now you can see the motion is on higher side, right? So based on this I can do any kind of a scenario, right? This is just a basic exploration. Let's say for example, if I want to change, I'll add this LED here. I'll just name to, let's say, red. Name is, let's say, extra LED, for example. Right? So this name is extra LED. I want to connect this to, let's say, this. Connected, done. Connection done. Done. This connect to 12. I want this to give a positive. So I have connected to, let's say, positive, for example. Done. Right? And then I can do the thing stuff here again, right? So you can add on the things as per your choice. Yeah, so there are all the components available. Let's say for example, if you want to see, let's say you want to see a serial monitor. So I think I should go with LCD. So now you can connect this LCD like this. You connect all these things here, and even you can see what is the rotation number is happening. Right? So it's up to you. The floor is with you. You can use any of the scenario where you can use. Even microbit you can use. I have the hardware of microbit here in with me. I have purchased this. It cost me around 12,000. It's a very good tool so that your kids can learn from this basic thing. It's a BBC micro kit. It's called. Right? Okay. So I'll have to delete this. Okay. Done. Right. So in that scenario, you can do anything you want to do with that. Right. So there is just basic components also there. You have all component. If you want, just go on to all. You have n number of components where you can use based on the application. Right. So based on the application, you can use DC motor, encoders, micro server. So this is micro servo, right? You can use IR remote, piezoelectric sensors, anything you can use based on the scenario, right? Okay, so based on this, I can hove around all that scenario, right? Where you can use this autonomous driving utility. So let's go here. Right now, let's say start simulating. See, if I'm coming this ball towards, right, it will do some different motion, right? If I am going like this, it means the distance it's calculate. Based on this, it will change that. Okay, where is the ball? So this ball is like an obstacle. If I coming close, it will move in this direction. It's like a steering wheel, right? If I go like this, it will again change. So you can decide the distance. What's the distance? So if I click on this, even we can decide what is the should be the distance. So if I click on this is the name, that's okay. And if you go to the code, right, so you can see at what distance you need to analyze. Let me check where it is. Yes. So if inches equals to this, if inches is greater than 70, right, then only your code will be running. It means if the distance of the object with respect to the ultrasonic sensor is greater than 70 inches, right, then you can do this steering wheel changing. Else you keep on this. It's like if you're going on an autonomous vehicle, if someone approaches very close to 70 inches, right, then only you change it, else you don't change the direction, right? So in that scenario you can use, so it's the way, else you can do the same thing. It means else you are sitting idle, right? So you can use your limit, right? And it's completely open platform. You can visualize and you can implement this thing in the real time, right? Okay, so there are multiple scenarios, right? I can go, let's say, all around, right, based on the flex sensors. Let's say if I want to tinker this, right, and if you want to start explore, these are the flex sensors, so it will work on flexing, right? Let's say for example, if I load like this will hover, right? If I flex this, let's say this, it will again change, right? So typically one finger will change, but there are some kind of a scenario where only that finger will try to move more where I am doing this change. See, this finger change, right? If I go like this, oh, sorry, now this finger will change. If I go like this, it's like I'm doing like this, this finger will change. If I again go here, if I go like this will change. It means, are you able to see this 101, 71, 64, 37, 89? Are you able to see this number? Anyone? Anyone? Are you able to see this number? This 101? Yes or no? Right? It means these are the angles at which I am rotating my finger. Right? If I go like this, it will become, let's say, 41. It's change from 81 to 41. Now if I change from 41 to more, let's say 90, 123, again it will went to 123. Now you can see the change over here, right? So these are like in flex sensors. If you keep on, let's say, giving force on it, based on that force, this will change. If you go for the code, if you want to go in the code, you can see you have defined all the fingers as thumb, index, middle, ring, and pinky. These are the number names of the fingers. You attach everybody to the pin, so it means thumb is attached to pin number 3. So let's see where is pin number 3, so that you can visualize. Pin number 3, I think this is pin number 3. This is attached to one finger, right? In the same scenario, you can attach the finger, and then you read the data from thumb, and based on this you print, and towards after printing you just directly feed the data into your motors, right? Okay. So there are n number of scenarios where you can use this. Let me admit, right, where you can use these criteria. Most ideally few examples, even you can have it over the Tinkercad, but the problem statement that I will be giving, definitely you have to make your own setup, right? And it's very fascinating, it's very good, and it will be a very good summer vacation homework for you, right? And maybe later in the stage we can develop this simulation part into real-time activity. So let's hope for the best, right? And if you have any issue, any concerns, just let me know. Anyone? Yeah. So ideally, what I am trying to planning is I'll be giving you 10 problem statements. Based on the 10 problem statement, you have to pick one, and in that every statement there will be three stages. Let's say beginner stage, intermediate stage, and expert stage. So for each, yes, for the same question. So for each question, you have to answer. You have to give solution for three sub problems, right? So I'll be giving you around 8 to 10 problems, and based on that, you can opt anyone. I'm not assigning, right? Based on your expertise, based on your interest, you can choose. But choose in a wise way that okay, whether it is going to help you in your upcoming time or not, right? And it is completely on individual basis, right? So you have to submit the things individually, right? Sorry. Yes, yes, yes. Any other query? Anyone? So that will be, I'll be sharing the document. So that's not a problem. You know? So that will I'll share. Sorry. You have to upload the photos. Working stage you can't publish, right? Because of the video हो जाएगी. है ना? हाँ, जी, जी, जी. ठीक है. Any other query? Anyone? So ideally, I'll be sharing a kind of a manual help after this meeting. I'll be sharing. I'll putting everything on the LMS so that everybody can access it. And based on the manual and based on the problem statement, you have to submit. I'll be giving a last date by let's say 30 June. So it will be enough time for you. And by tomorrow, I'll be sharing the helping manual and with the problem statement. I'll sharing both. Right. Okay, so sounds good to me, and I'll be very happy to see all of you here. And despite you have your summertime, right? So I thought I'll be having this session in the early morning so that watching heat, right, throughout the northern India. So looking forward to it, and hope for the best. Yeah. Any queries? Anything you want to ask? No? Okay. So thank you so much. And I'll be definitely reach out to you with the document latest by Tuesday night. I'll be putting everything on the LMS, and then we'll look forward to give you to have your solutions. I'll be checking each and individual solutions, right? And you have to submit on individual basis with the problem statement that I'll be sharing by end of tomorrow. Okay.